Hello everyone, I am Subha Mustaq. Today I would like to explain what is DC motor and their types of DC motor. First of all, what is meant by motor? Motor is nothing but the electrical energy is converted into mechanical energy. This is called as motor. There are two types of motor. First, AC motor. Second, DC motor. Today I would like to introduce what is DC motor and their working of DC motor. First of all, what is meant by DC motor? DC motor is nothing but the when DC electrical energy is converted to mechanical energy is called as DC motor. There are three types of DC motor. First, shunt DC motor. Second, series DC motor. Third, compound DC motor. Shunt DC motor is nothing but it is in parallelly connected. Series DC motor it is nothing but it is in seriously connected. Third, compound DC motor it is nothing but it is a combination of shunt DC motor and series DC motor. First of all, we have seen DC shunt motor. In this case, the connection between field and armature are in parallel. That's why this term is called as shunt motor. Now, this is the setup. How to your configuration to shunt motor. A field winding is supposed to be connected in parallel to the armature. So, as we have to cover the current relation, so plus sign is a current drawn from the supply and the supply will be through to the first in field coil and the second in brushed through the armature coil and the armature will be rotating and the current will be flow the both coil and the flux is created and this flux is interact to the torque is created and the small current is working and the back EMF is produced. This is how to be DC shunt motor is working. Second, we have seen series DC series motor. Now, as name is indicate, series it is nothing but the field winding and the armature winding is going to be connected in a series, and the operation of this motor mainly depend on the electromagnetic principle. When the magnetic field is formed, approximately the current carrying conductor cooperates with an exterior magnetic field, and then the rotating motion can be generated. The components of this motor mainly include the rotor, the armature, commutator, starter, axle, field windings, and the brushes. The fixed component of the motor is the starter, and it is built with two otherwise more electromagnetic poles parts. The rotor includes the armature and the windings on the core end to the commutator. The power source can be connected towards the armature windings throughout a brush arrayed to the commutator. The rotor includes a central axle for rotating, and the field winding must be able to hold high current due to larger quantity of a current throughout the winding, and the larger will be torque produced with the motor. Therefore, the motor winding can be fabricated with solid gauge wire, and this wire does not permit a huge number of twists. The winding can be fabricated with solid copper bars because it is a simple as well as efficient heat generated accordingly by a large amount of current flow during winding. In this motor, field as well as starter windings are coupled in a series by each other. Accordingly, the armature and field current are equivalent. Hertz current supply straightly from the supply toward the field windings, and the Hertz current can be carried by field windings because these windings have few turns as well as very thick. Generally, copper bars form starter windings. These thick copper bars dissipate heat generated by the heavy flow of current. The starter field windings S1 and S2 are in series with the rotating armature A1 and A2. In this series, motor electrical power is supplied between one end of series field winding and one end of the armature. When voltage is applied, current flows from power supply through the series winding and armature winding. The large conductors present in the armature and field windings provide the only resistance to the flow of this current. Since these conductors are so large, their resistance is very low. This causes the motor to draw a large amount of current from the power supply. When large current begins to flow through the field and the armature winding, the coil reaches saturation that result in the production of the strongest magnetic field possible. The, the strength of these magnetic fields provides the armature shafts with the greatest amount of torque possible. The large torque causes the armature to begin to spin the maximum amount of power and the armature starts to rotate and the flux is created and the flux is interact to the torque and the torque should be produce a small amount of current and the back EMF is produced. This is how to DC series motor should be produced. A third and last type of DC motor is DC compound motor. DC compound motor, it is nothing but the combination of shunt and series motor. It is also known as compound wood DC motor. This type of motor is self-excited motor and it is made up of both series and field coils S1, S2 and shunt field coils F1 and F2 connected to the armature winding. As we shown in figure below, both field coils provide for the required amount of magnetic flux that links with the armature coil and being about the torque necessary to facilitate rotation at the desired speed. As we can understand, a compound DC motor is basically formed by the shunt DC motor and this series DC motor to achieve better of properties of this type of motor. As we know that the rotor should be rotated and the flux should be created and the flux should be interact with and torque should be created and the small amount of current should be produced and the compound DC motor should be formed. So here are the explanation of DC motor and their types of DC motor. Hope you should have liked it. Thank you.